Hello everyone, welcome back to the past paper discussion video. In today's video, we are going to discuss question number 7 of AASL number 2022 paper, and it carries 16 marks. Let's break down and learn here. So a quadratic function f of x is given, its vertex and some more information like x-intercept. Intersect x-axis at x is equal to 5. These are the two things. We have to find f of x particularly in this vertex form, right? So let's start. So f of x is equal to a into x minus h the whole square plus k. This is the vertex form we know, right? And what is your vertex? Your vertex is h comma k in this vertex form. What is the vertex given? 3, 2. So now just replacing these values in h and k, almost the problem is solved. Only we need to find a. So x minus 3 the whole square plus 2. Now to find a, let's take the next clue. It intersects x-axis at 5. So the graph intersect x-axis at 5 means 5, 0 is a point on f of x. Is a point on f of x, which means I can substitute that point. Like this is x, this is f of x. It can be substituted in this, and this will fetch us what is a, and that's it, the problem over here. So f of x is 0 and x is 5. 0 is equal to a, we don't know, x minus 3. X is 5 here, minus 3 plus 2. That's it. Simplify it. This 2 will come here. It's minus 2 equal a times 2. You can cancel the 2 and you've got a is negative 1. Right? So we got a is negative 1. Okay, I think I missed something here. 5 minus 3 the whole square. So 2 square. 4a equal minus 2. Let's simplify it further. This will give us 4a equal minus 2. And this implies a is minus 2 by 4, which is minus 1 by 2. That's it. This is our a. Right. And next part. That's it. So our f of x is complete now. F of x is in place of a. I'm going to put minus 1 by 2. And x minus 3, this is already done. Plus 2. So we expressed f of x in the desired format. And next question. Another function g of x, it is also quadratic. Px square plus t minus 1x minus p. X belongs to R. P and t is also in real numbers, but p not equal 0. This plays an important role. And in this case, g of minus 3 equal g of 1 equal g of 4. So find p and t, range of g. Okay, the very first clue, g of minus 3 is 4. Let's apply it. G of minus 3 equal to 4 means you have to substitute in g of x. In place of x, put 3. That's it. So p times negative 3 square plus t minus 1 times negative 3 minus p equals 4. Simplify it. So this is minus 3 square is 9, 9p minus 3t plus 3 negative p equals 4. 9p and a p here. 8p minus 3t equals, when I switch the 3 here, it's 4 minus 3, which is 1. Okay, from the first, we got it. Let's solve the next part. G of 1 is 4. So p times 1 square plus t minus 1 times 1 minus p is equal to 4. So p plus t minus 1 minus p equals 4. This get cancelled, and now it's quite simple. T minus 1 is 4, t is 5. We got t value. How can I find p? Yes, it's just substituting t equal to 5 over here. This is quite simple. So 8p minus 3t equals 1. 8p minus 3 times 5 equals 1. 8p is 16. You know the reason. And p is 16 over 8, which is 2. So p is 2. Right? So we got first part is done. T is 5 and p is 2. We find it. That's simple. So next part, find the range of G. Let's go with that. Okay, before that, a quick recap on what is range of a quadratic function. Range of quadratic function. It's quite simple. You draw the quadratic graph and this is a vertex. So range means what? The y value ranges up to what? So it will range from the minimum point until the plus infinity in this particular case. If it's a negative, again, it's from the vertex, but it will go till minus infinity. That's the reason. So vertical stuff. So if your vertex is h comma k, this is my range. H is an input. So your y belongs to your y is actually basically greater than k, from k, and it goes on infinity. So this is the aim. Let's get into the problem. Range of G. Here we right. So g of x is given as px square plus t minus 1x minus p. And we know p and t, right? So we know that p is equal to 2 and t is 5. Let's substitute it. So our g of x reduced to 2x square plus 5 minus 1x minus p. G of x is 2x square plus 4x. Wait, p should be replaced with 2. Here, 2. And we got minus 2. This is my g of x. Now you find the vertex of it, and that's the thing. We can define the range. So next aim is to find vertex. You convert into vertex form. That is one method. Let's do. So g of x is 2x square plus 4x minus 2. I will teach you two methods over here. So first is converting to vertex form. Vertex form look like this: a into x minus h the whole square plus k. So completing square will be applied. Take the constant. X square should be purely with 1 as a coefficient. So here too, let me take it first. X square plus 2 is taken out, so 2x minus 1. Now how to complete this means 2 inside the bracket we need to work out something. So x square plus 2x, and this constant, let it be little, write it little away from the two terms, and we're going to add and subtract something here to compensate it. What I should add? So the coefficient of x, right? That number you have to divide it by 2. Coefficient of x is 2 and divided by 2, whatever it is. If coefficient of x is 10, 10 divided by 2. So we are making half of the x coefficient, which is 1, and you need to square it. And then that value you need to add. So I have to add 1 square. Hope you get the reason why we are doing it. I close the bracket. Make sure the 2 is out. And inside the bracket, all these things still. Now something I have added, and the x terms and the added terms will become complete square. Can you can note it, right? A square plus b square plus 2ab. Right? So you can write x plus 1 the whole square. The first 3 terms. And minus 1 minus 1, it's minus 2. Now you take the 2 inside. 2 into x plus 1 the whole square minus 4. This is our desired vertex form. This is method 1. Using completing square. Now, next part, method 2. It will be very similar to that. Just give me. Okay. So the next part is the different method. Method two to find the same. So how we're gonna do? It is finding vertex is what our aim. Vertex x coordinate is minus b by 2a. And vertex y coordinate is whatever your function, substitute that minus b by 2a value. Okay, here my g of x is 2x square plus 4x minus 2, right? So we know what is a, b, and it is from the standard form. My a is 2. So x is minus b. B is x coefficient. This minus is in formula by 2 times a is 2, which is minus 1. Right? And y is g of minus 1. Whatever your function, substitute in that function. So 2 times minus 1 square plus 4 times minus 1 minus 2. And it is 2 minus 4 minus 2. 2 minus 2 cancel, minus 4. So my vertex is minus 1 minus 4 in this way. In that previous way also, it's very similar, right? How will you fetch this? X plus 1. So whatever it is actually plus 1, but your vertex is minus 1. X coordinate will act like that, and y coordinate just copy as it is. This is my vertex. Anyway, the vertex is same. Now coming to the conclusion, what is the range? Range is f of x, oh, we are dealing with g of x. So g of x greater than or equal to y coordinate of the vertex. Or you can write in interval form minus 4 comma till infinity. Right? So that's it. This is the range of the function. Now the next part, j of x is given like it's a linear function minus x plus 3p where x belongs to r, p belongs to r, but p not equal 0. We have to prove that j of x and g of x have two distinct points of intersection for every possible value of p and t. Okay, so let's see how to solve this. Let's break down this step. Okay, whenever the graph intersect, algebraically what we can do, we can equate them. So that's the thumb rule. When graphs intersect, meet, you can equate them. Sorry, it's intersect actually. Intersect. And we got what we should do, j of x equals g of x. And whenever they, they will meet for every possible values. So intersection, and it's always two distinct points of intersection is what we need to do. So let's get in, let's break down. First, let's equate and simplify it. J of x is minus x plus 3p. And what is g of x? It's given, I'm just copying it. Px square plus t minus 1x minus p. So keep that p and t as it is. Don't substitute, already we find p, right? Don't use that over here. So minus x plus 3p equal px square plus tx minus x minus p. Simplify it. Let me take these two over here and I will get px square plus tx minus x minus p, and minus x if it transpose it's plus x, and plus 3p will come as minus 3p. equals 0. Now cancel out minus x and plus x and simplify it further. We got px square plus tx minus 4p equals 0. Right? And okay, this is my equation. This equation is formed under the condition like the two graphs meet, j of x and the g of x. Okay, so we know if it's a model of a quadratic equation. So in quadratic equation, we know the nature of the roots, right? So when two intersection these distinct points means my discriminant will be greater than 0. Okay, so that's the thing we are gonna apply here and find the discriminant and put greater than 0. And we need to prove it, right? Let's see. So discriminant is actually b square minus 4ac. And what is my b? It's t. 4 times a is p. C is minus 4p. And let's simplify. T square plus 16p square. My aim is, if they are meeting, okay, my aim is to prove they meet at two distinct for every possible value of p and t. That's why I said no need to substitute p and t here, because that will become a one case. We have to show for every possible value of p and t. Okay, so now t square, t is belongs to R. So what happens to t square? T square will be greater than 0 for sure. T belongs to R, and this implies t square is greater than or equal 0. But P, we have a condition like this. P belongs to R, but P is not equal 0. So what does it? P square will become greater than 0 because equal 0 is not possible. P can't take 0 means P square also won't become a 0. So what happened to 16P square? That will be also greater than 0. So my del is first value is greater than or equal to 0 plus the second value is greater than 0. This is just for explanation. You don't need to mention this. The reasoning behind this. Okay, you are putting a greater than or equal to 0, sometimes 0, and here a greater than 0. For example, 1 or something. So for sure, it's going to be strictly greater than 0. Right? So this implies del is greater than 0. And since I have proved del is greater than 0, it means, and my equation is purely based on P and T, right? So this implies j of x and g of x intersect at two distinct points. For every possible value of t. We didn't do for one case, we just did it for general case. For every possible value of, sorry, p and t, right? So this complete the solution. That's it, and very simple question from the quadratic function. Thank you so much for listening. Let's meet in next video.